Okay, we are going to look at Feynman diagrams, and we're going to break them down into the 4 fundamental things that can happen. First, let's say we start out with an exchange particle, and we'll use a squiggly line for all exchange particles. The exchange particle reaches a vertex, and what happens? It disappears, and in its place we have a matter particle and an antimatter particle. So earlier in time, here's the vertex, and if we look down the axis earlier in time, there's an exchange particle. If we look up the axis later in time, we have a matter-antimatter pair. So we call this pair production, because we're producing a matter-antimatter pair. Next up is the opposite. A matter particle and an antimatter particle meet, and then they annihilate, producing an exchange particle. So if we look, again, here's the vertex right there. If we look earlier in the time axis, we have these, the matter particle, the antimatter particle, and if we look later on after the vertex, then we see that neither of those is there, and they've been replaced by this exchange particle. So we call that process annihilation. It's the reverse of pair production. They're kind of opposites. Next up, something pretty straightforward. Here is, let's say it's a matter particle, and it emits an exchange particle, and afterwards it remains a matter particle, like this. There's no official name for this. I'll call it emission. And here's how you can visualize what's happening. We have some matter particle, maybe it's an electron, let's say, and this thing is moving along, and then all of a sudden it emits, maybe it's a photon, and the photon goes along, and maybe the electron deviates and follows a different path because of this. That's the emission. There is a more complicated scenario where the electron is going along and it emits this exchange particle. Maybe it's not a photon, maybe it's a W boson or something, or a Z boson. And then afterwards, the electron turns into a tauon, or a tau particle, and it follows this different path, and the Z boson moves along. So it is possible, both are possible. You could start with like an up quark and end with an up quark, or you could start with a strange quark and end with an up quark. So you can actually change from one to another. The next process is very similar. Instead of emitting a particle, this matter is going to absorb an exchange particle. So now the picture we can think of, here's the electron moving on its happy way. Here comes a photon, and the electron is moving along, the photon is moving along, and bam, the electron absorbs that photon. And then maybe the electron moves in a different direction because of it. And just like we saw before, it's possible to have this, maybe it's an electron, and then it remains an electron afterwards. Or maybe it starts as an electron, and then it, changes into a muon, or a tauon perhaps, a tau particle. This is called absorption. And it's worth pointing out that, this could have been, here, it could have just as easily been an antimatter particle. And then here it's an antimatter particle. And likewise, this could have been antimatter. Same here. I'm just using matter for simplicity. These are official names. You want to make sure you're super familiar with them. These are names I've just kind of made up to try and capture the process. All right, let's take this then as a springboard for something more complicated. Here's my time axis. And I want to consider, I would like to consider the scenario where a neutron turns into a proton. So a proton has a positive charge. Let's try this again. Proton has positive charge. Neutron has no charge. So then, well, wait a second. Where's this positive charge coming from? If you create positive charge, you have to create negative charge as well, so that the net stays at 0. So then, in this process, we also create a negative beta particle, also known as an electron. But we can't just create this electron. I mean, the neutron kind of changes into the proton, and then this is created anew, just kind of out of thin air. But you can't just create matter. You have to also create some antimatter. And so the antimatter we create is an antineutrino. But what's in a neutron? What's in a proton? What are the quarks inside those? Here's how I remember. A proton is not a proton, it's a proton. It's a proton, bruh. Duh, bruh, proton. A proton is an up, and then a down. So the proton is up, up, down, and the neutron is the opposite, up, down, down. Now the up here doesn't change. This up stays an up. The down here doesn't change. That quark stays the same. But this down is turning into an up. And that's how we can think about this positive beta decay. We're changing a down quark into an up quark. Let me leave that up. So I'm going to move this over along with the whole thing. So that's where we start. We're going to draw an up quark. Let me do this like so. This is an up quark, and it changes into a down quark. Oops, I got it backwards. It's a down quark, changing into an up. And what happens? Well, I've got, at this vertex here, what am I missing? An exchange particle. This exchange particle can't just disappear, and in fact, we know what's going to happen. We're going to have pair production. But look at what we have so far. Right now, currently, this looks like emission, right? I mean, we've got one thing emitting an exchange particle and then kind of moves along, continues to be matter. It's changing from down to up, but this is a picture for emission. Then, forget this stuff for a minute. Forget this and this. Now what we're going to do is draw, pair production. Because this exchange particle turns into the matter-antimatter pair. Okay, let's draw that. You've got some matter, and you've got an antimatter particle. The antimatter particle, that's the antineutrino. The matter particle, that's the electron. So it's like we're combining this picture with this picture, and this is it's one and the same exchange particle. They are connected. That's pretty cool. If we want to get really fancy, here's what we can do. We can say, all right, draw the rest of the neutron. The neutron is not just a single down, it has another down and an up. So here's the other down, And notice how nothing is happening to that guy. It's ending as a down, it's starting as a down, and there's no interaction at all, right? It's not ejecting anything or emitting or absorbing. Then here's the up quark. And it stays an up quark. So these three together make the neutron. And these three together make the proton. And that's kind of the fancy pants way of drawing this reaction with the three, the three lines.